Hey everyone, we are going to take a look at net ionic reaction equations, and specifically we're going to, as an example, use precipitation reactions, which are reactions that produce a solid when solutions are combined. So the example I provided here is we have aqueous solutions of lead 2 nitrate and potassium iodide, and they're going to be combined, and we're asked to provide the full reaction, full ionic reaction, and net ionic reaction equation for that process. All right, so we're going to start by writing our reactants. We've got lead 2 nitrate. Now remember, the Roman numeral here tells us that the lead is in a 2 plus charge, has a 2 plus charge. Nitrate is always -1, so that means we need 2 of the nitrates to make that neutral compound. We're going to write the state symbol behind it because we're told that these are aqueous solutions. You're not always told it's aqueous solutions. If it's dissolved in water or it just says solutions, we are always going to take it that means it's dissolved in water. And then our other reactant is potassium iodide. Potassium is a group 1 ion. Iodide is from group 17. Those are +1 and -1. It's already neutral, so we're done there. Now we're going to come up with our products. And what we have here are two ionic reactants, right? So the fact that you have a cation and an anion, cation-anion situation means that the only possible new combination is to have this cation now reacting with this anion, and this cation with this anion. That's the only possibility because you can't have two cations together in a compound, right? So that's going to mean that we're going to have lead, which it's still 2 plus charge, iodide, which is always -1. So that means we need 2 of the iodides. Oops, sorry. We go, this is not aqueous. We go and look at this on our solubility table. This is a solid. So this is going to be our precipitate. And then the other compound that gets formed here would be potassium with nitrate, which is soluble. And we're going to see this over and over. Anything with a group 1 ion is always going to be soluble in water. Also, anything with a nitrate in it is always going to be soluble. So that compound is definitely soluble. So that's our full reaction. I'm going to clean this up just a smidge. So now we are going to come up with our full ionic reaction equation. The full ionic equation, we just separate ions for soluble ionic compounds, right? So this is soluble, it's ionic, it's going to dissociate, as we've seen several times, that's going to dissociate. I'm being a little loose with the coefficients here, as I tend to be. Because there are 2 of these, we really ought to put a 2 out in front here. I find that confuses things, so I'm going to drop the coefficients. Just be careful, or just be aware that it's not, I mean, we didn't even balance the full equation. So if you're asked to balance, you should do that. But generally speaking, my goal is to get to the net ionic, so I'm not going to worry so much about it. All right, potassium iodide is also soluble, so that's going to dissociate. The lead iodide is insoluble, that stays together. Potassium nitrate is going to dissociate. So that's our full ionic equation. To get to the net ionic equation, we're going to look and see which things are exactly the same, state and charge. Oops, I did not write a state for my nitrate, that's aqueous. What things are different state, or the same state and charge on both sides? Those are going to be dropped out. So notice that potassium is +1 and aqueous on both sides, so we are going to drop that out as a spectator. Same is true for nitrate, right? It's NO3, it's -1, it's aqueous on both sides, that's a spectator. Notice that the lead over on the reactant side is dissolved in water. Over here, it's part of an ionic compound, solid, so that's a change. So we're going to leave that in, same for the iodide. So now we just bring down what we have left. Well, maybe. We're going to bring down our Pb2 plus and our iodide. And that's going to still have our lead iodide on the product side. And that's it. That's the net ionic reaction equation. A lot of times you're going to be asked to balance the net ionic reaction equation, which is pretty straightforward. We just put a 2 out in front of the iodide, and we're done. All right. So the point of the net ionic reaction equation here at the bottom is that we're only showing the things that actually reacted. So the visible Q that we're going to see in lab is the formation of a solid. The solution actually is going to turn cloudy at first, and then this solid lead iodide is going to appear to rain down from that cloud of solution. That's why it's called a precipitate, because it's like rain coming out of the cloud. And that precipitate then is going to eventually settle down to the bottom as a powder solid. Okay. All right. Hope this was helpful.